This is our killer capacitor demonstration. The capacitors are three 6.7 microfarad capacitors rated for 20,000 volts. These capacitors are connected in parallel, yielding a total of 20 microfarads. An example of a 20 microfarad rated for 16 volts is here. Clearly it's much smaller, and so the primary difference is the voltage rating. In order to achieve the high voltage rating, the capacitors needed to be much larger. Now, we also have a knife switch separating the coil from the capacitors. This knife switch allows us to safely charge our capacitors to 10,000 volts and not have any fear of it discharging unexpectedly through our coil. On the back, we have a meter, and this meter is very large and allows us to tell very easily how high our voltage is on the capacitor. And then on the front is the business end of the killer capacitor, our 4-turn coil. And the 4-turn coil is set in a platform so that you can easily set things on top of it without any fear of the capacitors hurting you, especially when they're not charged. And so what we use this to do is we have a complete ring which the killer capacitor will throw in the air. We have a split ring which the killer capacitor will not affect. And then we have a split ring with aluminum foil bridging the split. When the killer capacitor is discharged, the electromagnetic induction from the coil will cause the aluminum foil actually to explode. And then our grand finale with the killer capacitor is we rip a soda can in half. All right, let's get to it. So first we'll start with the continuous ring. We'll place our ring on the platform on top of the coil. We will then raise our knife switch so that the capacitors can be charged. And we will charge up the capacitor bank to 6 kilovolts. And this will take some time because it is quite a high voltage. And we are just using the power from the wall going through a variac and into a 10 kilovolts DC power supply. All right, we're all charged up. And now let's see the ring jump. 3, 2, 1. Now let's see how the split ring reacts to our killer capacitor. Once again, place the split ring on the platform. I will raise the knife switch, and now I will begin charging the capacitor bank. For the split ring, we typically charge it up to the same voltage that we charged up the capacitors up to for the continuous ring, and that's just for continuity. Typically, we'll ask the students what was going to happen when we fire the killer capacitor, and they'd find out in 3, 2, 1. And so the split ring clearly didn't react at all to the discharge. Now we'll move on to more of the fun stuff. And so this is the split ring with foil, aluminum foil bridging the split. And for this one, we make sure that we place the ring with the foil facing the students, and we always cover it up because the foil is going to explode and burn, and it could hurt someone. And so we raise our knife switch and begin charging. For the aluminum foil, we charge it up to 8 kilovolts. So we do not fully charge our capacitor bank, but 8 kilovolts is higher than our continuous aluminum ring. And we also are always sure to wear ear protection whenever we go over the 6 kilovolt mark. And so now we're at our 8 kilovolts. So let's see it explode in 3, 2, 1. And so clearly, when the split is bridged with aluminum foil, our ring will both jump and the aluminum foil will explode. And now for the grand finale, we're going to split a Coke can. Now our coil is actually set up specifically so that we may insert the can into the middle of our coil, cover it back up again, and now I will raise the knife switch and begin charging. And this is all the way up to the 10.5 kilovolt mark. And as you can see, the can is both a little bit above and below the coil. And so we ask, what will happen? Will the coil throw the can up and down? Will the coil not do anything to the can because there's some above and some below the can? Will the can get ripped in half? Will the can just crush into one little ball? You know, there are several different options people normally suggest for what's going to happen to our can. And now we're up to the 10 kilovolts. All right, we're fully charged, and we're going to split our can in 3, 2, 1. Right. So clearly, our coil was able to rip the can in half. Now, as you can see, it's smoking, and that smoke's actually from the burnt leftover Diet Coke, in this case, that was left in the can. And that's because there's a lot of heat created when the metal is deformed so quickly. But there's clearly a difference between the top half of the can and the bottom half of the can. And now, why is that? Well, there's a hole in the top part of the can. And so the hole allowed the air in the top half to come out, and in the bottom half there is no hole. So there's no place for the air to go. And so when the air was compressed by the crushing of the can and heated by the heat from the crushing, it is then exploded outward because there's no place else for it to go, and unsort of crushes the can bottom.